In our previous video, we established understanding on using reduction formula to solve the form x raised to power n sine x dx, and we arrived at this conclusion. Now let us determine a reduction formula for integral of 0 to pi over 2 of x raised to power n sine x dx, and then we are going to use that expression to evaluate 3 theta raised to power 4 sine theta from lower limit 0 to upper limit pi over 2. So let's begin. We know that In is equals to x raised to power n sine x dx, which is minus x raised to power n plus x plus nx raised to power n minus 1 sine x minus n into n minus 1 of n minus 2. So In has an integral of this. So what if it is now from lower limit 0 to pi over 2? Therefore, we'll have to apply our upper limit and lower limits from 0 to pi over 2. So wherever we see x, we apply the upper limit first. That's minus pi over 2 raised to power n plus pi over 2 plus n into pi over 2 of n minus 1 and sine pi over 2 minus n into n minus 1 in minus 2. Then we'll have again minus. Then we apply our 0. Wherever we see x, we put 0. That's 0 raised to power n plus x plus n into 0 raised to power n minus 1 sine x minus n into n minus 1 of in minus 2. Now this nullifies to give 0, likewise this. Cos pi over 2 is 0, so the term here nullifies to give 0. And now these two terms have no respect to x, so they are constant. Therefore, we'll be left with n pi over 2 n minus 1 sine pi over 2 minus n into n minus 1 in minus 2. Now if cos pi over 2 is equal to 0, then sine pi over 2 is equal to 1. Therefore, n minus 1, since this is equal to 1, then we have just minus n into n minus 1 of in minus 2. Now this is the reduction formula for x raised to power n sine x dx from 0 to pi over 2. And now with this done, we can now evaluate the question. The question says integral of 0 to pi over 2 of 3 theta raised to power 4 sine theta d theta. Now 3 is a constant, it can be brought outside. That's 0 into pi over 2 of theta raised to power 4 sine theta d theta. Now we can rewrite this, all of this, to give us in. Okay, so we know that n here is equals to 4. Therefore this will give us 3i4, because everything from here is i4. So let's make our substitution of i4. So wherever we see n, we substitute 4 in this equation. So now we have 4 pi over 2 raised to power 4 minus 1 minus 4 into 4 minus 1 I subscript 4 minus 2. This is just I4 and it will multiply 3. So simplifying this, we have 3 into 4 pi over 2 raised to power 3 minus 4 into 3, that is 12 I subscript 2. So we now have to find an expression for I2. So I2 will be when n is equals to 2 in In. So wherever we see n, we'll change it to what? To 2. So that will give us 2 into pi over 2 raised to power 2 minus 1 minus 2 into 2 minus 1 into I2 minus 2. So this will give us 2 into pi over 2 raised to power 1 minus 2 into 1, that is 2 of I naught. So this is an expression for I2. Now we can see that from I2 we still have to evaluate I naught. So I naught is what? We know that In is integral of x raised to power n sine x dx from 0 to pi over 2. So now let's make our substitution of I is equals to 0. So I naught is integral from 0 to pi over 2 of x raised to power 0 sine x dx. So this is integral from 0 to pi over 2 of sine x, because x raised to power 0 is 1 dx. So this will give us minus cos x, because integrating sine x will have minus cos x, and the limit is from 0 to pi over 2. So substituting our upper limits, we have minus cos pi over 2 minus the lower limit, that will give us minus cos 0. And we know that cos pi over 2 is 0 and cos 0 is 1. So altogether I naught will be equals 1. So since we have an expression for I naught, we can now substitute I naught into I2 so that we can solve for I2. And we know that I2 is equal to 2 pi over 2 raised to power 1 minus 2 I naught. Therefore, substituting I naught now, we'll have 2 pi over 2 minus 2 into 1. So this will give us pi minus 2. Now we have an expression for I2. Now let's go back to our question itself, and where we know that integral of 0 to pi over 2 of 3 theta raised to power 4 of sine theta d theta is equals to this. So we can note this and then we write over there and then we substitute our I2 into this, such that we will have 3 into 4 pi over 2 cube minus 12 into pi minus 2. So simplifying further, you will have 3 into 4 pi raised to power 3 over 8 minus 12 pi plus 24. So this will give us 3 into 2 pi, or pi raised to power 3 over 2 minus 12 pi plus 24. And using our calculator and simplifying to 2 decimal places, we'll have our final answer to give us 5.41.